9 project ideas to build over the next 1 month. 2 of these projects were capstone projects in Super 30, and most of the interviews happened around the projects. In fact, I dare to say around 30% of the interviews were purely on one project over there. That means once the student sat in the interview, the full interview was around how did you build the project, and then diving deeper, more and more questions in the same project. So pretty aggressive projects. They're present in 4 niches. I'll talk about the niches and the specific projects people hire with us usually in these 4 niches. Hence, I picked them. And also, if you feel like you can build an end-to-end project in the next 1 month, have it productionized, a live link and a GitHub, do tag me on Twitter and I'll see if I can connect you somewhere. But make sure it's prime towards the end. I'm assuming around 4 or 5 people will be able to create it end-to-end. Also, if there is any project you want me to build live or in an offline video, just comment that below. Whatever is the most upvoted projects amongst these 9 is one I'll be creating in a video. With that, let's get right into it. The project ideas are divided into 4 niches. That's HFT, DeFi and Web3. AI, full stack, and front end and design. This 4th one I added because surprisingly around 30% of our referrals are happening in design engineer roles, which means someone who knows front end but also has an eye for design. The very first niche is HFT, DeFi and Web3. And the very first project is a sports betting platform. IPL is on, and I don't know how many of you bet, hopefully not a lot of you, but this platform is a little different from Dream 11. When you go to the platform, you have a bunch of markets like these. For example, will Bangalore win the match against Chennai? This is a match from yesterday. And notice there is a graph below where people are trying to trade on the opinion whether or not Bangalore will win. So I could have bought the Bangalore stock for 60 rupees over here or 6 rupees over here. And if Bangalore won, then it would eventually reach a price of 100 rupees or 60 rupees. So if I bought it for 6 rupees over here, it would eventually reach a price of 100 rupees. So I would make 40 rupees. If Bangalore did lose, then I would make 0. So it's basically probability based betting. Initially, if you look at it, Bangalore was a little expensive because Bangalore was favored, and hence it was a little expensive to buy the Bangalore stock for 60 rupees. But if you won 100 rupees. If you bought the other stock, which is the Chennai stock, then you would have bought it for 40 rupees. And that would have also gone up to 100, but the probability was lower. And indeed, the Chennai stock went down to 0. The Bangalore stock went up to 100. So the way these platforms work is very close to how a trading application like a 𝗟𝗶 or a Binance works, which is there is a centralized order book where people are trying to place orders. This is what an order book looks like. Here is another platform called Polymarket where there is the Punjab Kings versus Delhi Capital order book where you can buy the Punjab Kings stock for 58 cents. And if they win, then you win $1. If they lose, then your 58 cents goes down to 0. If you want to sell, you can always sell it as well. But the spread here was really high. You have to build something similar, either sports betting markets on Polymarket or sports betting markets on Probo. Both of these platforms let you trade on other outcomes as well. For example, will Trump win or will Hillary win? Things like these as well. But generally the way you use them, or I would like for you to use them, is just a use case on top of it, which is a subset of the markets that exist over here. A bunch of cricket or basketball games, people can trade on them and win or lose. If you look at this specific graph from yesterday, you'll notice originally the price of the Chennai stock or whoever won Bangalore stock was 60 or 0.6 cents, let's say, or 60 rupees. Then it went down a little to 50 rupees because they probably might be losing, and then it went up because they might be winning, and then there was a wicket, then it went down, there was DRS, another wicket. So it dropped down really low when 2 wickets happened together. So you could buy the Bangalore stock for literally 30 rupees over here. And if they won, which indeed they did, then you would have made 100 rupees. So that's almost 3x you could have multiplied your money if you bought it right when there was a lot of tension in the market. There were 2 wickets together, and hence people thought Bangalore would lose. That's how these platforms work. It's not like they're calculating the probability themselves. The probability is purely based on supply and demand. There is an order book where a lot of people are placing orders, and based on that, the current price of the stock is being decided. So in the end, it's very close to buying a stock, but the stock will eventually either land to 1 or it will land to 0 based on if that specific team wins or not. You can buy the Bangalore stock, you can buy the Chennai stock. If Chennai wins, the Chennai stock will go up to 1 and the Bangalore stock will go down to 0, vice versa. So it's very close to buying a Google stock or an Apple stock, but at a specific timestamp, it's either going down to 0 or going up to 1. There are technical challenges in building this. I would urge you to go to my 𝗟𝗶ः video to understand how order books work. And then there are some more nuances on top of this. I'm not explaining it end to end. Maybe I will upload the 𝗟𝗶ः video one where we discuss this architecture, because yeah, even if you know how trading works, this is a little weird because there are two stocks that you're trading in a single market, and you know, trying to build this platform on top of it. The general things you're going to learn are order books, async architecture, and low latency. The reason I mention low latency is because people who are making this market liquid, people who are adding a bunch of these orders, are very close to market makers like Citadel. I don't think market makers or traditional stock market traders are trading on opinion trading markets like these. They might be, but they expect really low latency, which means, you know, if you're building the backend, maybe don't build it in a Java or a Node. Try to build it in Bun at the very least, or C or Rust, a language that's a little faster, because market makers would expect the order time and execution time to be really low. Cool. That's platform number one. It's very close to an exchange, but it's a very specific use case, and there are nuances in building something like this. The project is a sports betting platform. Just go to probo.in, try to explore, and you'll understand. Second one, on-chain order books. So this one is the same thing as the last slide, but on-chain, which means you're building an order book on the Solana blockchain, on Ethereum. There have been experiments to do this in the past. Serum was the very first order book back in 2022, I think, if you've been through the early days of Solana. Serum did not work out eventually, and I think OpenDex was forked from Serum. I could be wrong, but they're also not working well anymore. They're not actively maintained, because order books are generally hard to execute on a blockchain. Blockchains are slow, and whenever you see an order book like this, these orders are being placed very quickly, and they're being cancelled very quickly as well. So whenever you're placing an order on a centralized exchange, you don't pay any fees. But if you're on a decentralized blockchain, every transaction you have to pay some gas, and also every transaction is really slow, and hence no market maker would want to trade on an on-chain order book. That said, there are ways to work around this, specifically if you're trading on an L2, which is, you know, faster, or a gasless L2, which doesn't have, where you don't have to pay for every transaction that you're doing, and the L2 eventually rolls up to an L1. So this project idea I actually got from a hackathon that an L2 is doing. So if you do build something like this, you should aim to deploy it not on an L1 like Solana or Ethereum. You should deploy it on an L2, and preferably one which is really fast, has really low block times, and also does not charge for every transaction that is happening. Cool. Here is the code for it. If you've done Solana development in the past, if you have written contracts, you'll be able to understand most of it. As long as you understand what are bids, what are asks, what are limit orders, market orders, how an order book works. It's just the same code that you might write in Node.js over here, translated into Rust, and, you know, in a specific format that chains understand. Cool. These are the two projects. This is probably, you know, nirvana when it comes to building something on chain. If you're able to build this, you'll be able to build any other smart contract in the future, like lending. Maybe perps is a slightly more advanced use case to build, but any simpler contract like a token launchpad or a token marketplace or an AMM is easier to write compared to a DEX on chain, or sorry, an order book on chain. Cool. Two aggressive projects. Project number one, the one that was heavily asked in interviews for 𝗟𝗶ः when people build this, you know, themselves. It was built in three phases in 𝗟𝗶ः. So there was Probo V1, Probo V2, Probo V3, because we just kept on making the architecture better and better. This one is, you know, again, you should build it to learn Rust really well. There is a very low probability that this actually finds PMF, because it hasn't, at least till today, on-chain order books haven't found great PMF. Cool. Moving on. Second niche over here is, I've called it LLM parsers, because most of these websites talk to an LLM, get back a response, and the primary effort goes in trying to parse the response from the LLM. What is the LLM instructing you to do? Hence, I've named this section LLM parsers or agents. The very first project over here is Cursor for Blender. That assumes you understand what Blender is. Blender, not a Blender. Blender is a 3D modeling tool, animation tool. It's like Maya or OpenCAD. If you've seen them, you can create 3D models in there. It's really hard to learn. There's a very high learning curve. I've gone through tutorial hell in trying to learn it back in school. And thankfully, AI is here now. AI makes coding easy. AI makes something else easy. AI also makes working on top of Blender very easy. So you don't really have to understand the buttons that exist inside Blender. You can talk to an AI. The AI can execute scripts to do what you want. So you can ask the AI to create a scene with a bunch of mountains and a hero running. And the AI will execute it for you inside Blender. There are two variants of this. One is what was released over here in this tweet. So I'll link the tweet in the description. This is a little different from what is being asked over here, which is Blender now has an MCP server that someone released. That means this has all the functionality of Blender exposed over the MCP protocol. So all that you have to do is run this on the user's machine, run Blender on the user's machine, and then maybe create a native application, a desktop application for them, where they see a chat interface, they talk to the chat interface, the chat interface talks to the MCP executes the final commands inside Blender. So what is the project that I am proposing? A native application where people come and type something like create a scenes with mountains. That specific call gets forwarded to an LLM. The LLM asks the MCP to do something, which in this case could be, create a mesh and then populate the mesh in 10 different places so that a mountain scene is created. And the MCP talks to Blender and actually executes it. The other variant of this is this, which is, sort of exactly what we want, cursor for 3D modeling. But here there is one specific use case that an LLM would not suffice with, which is probably might actually through visual. Basically, it may and you might need something more than an LLM here. The use case is you post an image or you create an image of a house, let's say, and that 2D image gets generated or converted into a 3D mesh. So you're not supposed to spit out text. You're actually supposed to spit out a mesh, a 3D mesh of a house or a mountain or whatever the user has drawn in the 2D space. This is not very easy. In fact, a friend of mine is actually working on a company that does exactly this, and they're just doing research right now and only have like 20 clients or 20 people using it. It's a hard research problem. I don't know if there are easy tools that let you convert images to 3D. That said, this one is an easier one and probably the one that most people would want to use, an application to talk to Blender through AI. The second one is more interesting. It is a very similar use case, but there is no Blender over here. There is an animation library on the right, and the one that I'm suggesting is Manim. In fact, I've already tried, experimenting with this locally, and it works really well. Let me see if I can find that specific file. So yesterday I was experimenting with this specific framework, and I was able to create this video purely through AI. So I gave the AI a prompt, something like create 3 boxes. First should say client, second should say server, third should say cache, fourth should say database, and show visualization amongst them. As you can see, it's able to do something like this. If there's a cache miss, then the arrow should go over here. So you can keep re-prompting the LLM to generate not a video, because LLMs can't generate videos, but LLMs can create code. So you can ask the LLM to write a bunch of code that uses this library that will eventually, spit out a video for you. So Manim is an animation library or a video library or a 2D game engine, not a game engine, but a video animation engine that a very popular channel called 3 Blue 1 Brown uses. If you've ever seen Transformers videos, or if you ever want to learn about Transformers or general machine learning and deep learning, it's a great channel. And all of his videos are made using scripts like these. It's just really hard to write such long code to create something. But thankfully, LLMs are really smart at writing text, and once this text is written, this library is really smart at spitting out videos. So if you want to create a cube like this where a bunch of squares finally land up on the cube, all you have to do is ask an LLM to give you a very long script that uses Manim to generate that specific scene. It will give you the script, compile the script, generate an MP4, and you're good to go. So the final expectation from the platform is a website where people come, they write their script over here, create a scene where there is, what did we create over here? We created a client server like model where there is a browser on the left, a browser box on the left, a server box in the middle, a database box on the right. Write the script for it is what you ask the LLM. The LLM writes the script, you execute the script, you spit out the video. That is what the end user sees. So the user may or may not see this code. So you can build something very close, like very similar to Bolt or Lovable. But what they're generating is not a website. What they're generating is a video. So the UI interface can look exactly the same. The only difference is when you ask it to do something, it is not writing React code for you. It is writing, Maxim or a different library. P5JS has a similar library that lets you create visualizations. So it writes code in that specific library, which when they click on a compile button, spits out the final video. The good thing about this is when you are generating these videos, you have to create like 20 different scenes. So you can ask the AI independently to create 20 scenes. You are not creating a very big project. That is not true for software development. If you're creating a React website, it will keep getting bigger and bigger, and then the LLM loses context. But if all you have to do is create 20 different scenes that are really small, 5 to 10 seconds, then the LLM won't hallucinate. So you can keep reprompting it to create scene 1. After you're done with it, you can reprompt it to create scene 2, scene 3, scene 4, so on and so forth. And a great feature to add over here would be a video editor sort of a UI, where whatever animations I've asked it to make, I can compile them together and render them together, maybe add a voiceover on top. That way it becomes an end-to-end AI application to generate videos for your, educational videos. I would assume that's probably the best use case for creating for this library at the very least, because it lets you do visualizations closer to, how an LLM works or how a transformer works. That is, or, quantum computing. This guy does a lot of things, but the person who created this library has a YouTube channel as well called 3 Blue 1 Brown. Go to the channel, amazing channel, and you'll find the kind of videos that you can finally create through this animated website that you have created, or feel free to create a native application as well. This is the one I'm most excited about. This is the one that I've already experimented with. Probably I'm going to release a video on this, but beat me to it and yeah, build it before I do. Cool. That's idea number 2. Idea number 3 is Same.dev, which is very close to Lovable and Bolt if you've used them. A website that generates React code or other websites. Only difference is it has one extra challenge. This requires you to write some code. This requires you to provide the final website that you want to clone. So you might want to clone Facebook.com, Google.com, a competitor. Just give it the URL to that website and it will clone it end to end. At the very least, it will clone the landing page or whatever pages you're trying to clone. So it needs to gather context of the website that you're trying to clone. So the things to learn over here would be indexing websites. If a user comes over here and provides you a website, I want to clone football.com, your server needs to hit football.com. It needs to understand the layout. It needs to understand the sections. It needs to understand the styles and forward all of that to GPT, which will eventually create the full website for you. And there's a lot of follow-up prompts that you need to do. So it's not just a single LLM call that you'll make. You'll probably make 20 LLM calls trying to improve the website. And the final goal is the user is able to clone whatever website they want, let's say facebook.com or football.com. It would involve GPT APIs. It would be good to add remix functionality, which means I have a marketplace like this where I can see other websites that people have created. I can remix them and build on top of it. And lastly, user-specific deployments and workflows. This is just an extra infrastructure challenge that comes in an application like this. I've already covered it in 2 videos. So you can go to my Bolt video where I tried to clone Bolt. There's another video I made where I tried to create a website that creates mobile applications. Think of them as decent starting points for Same.dev, but honestly, there's decent starting points for this project as well, because both of these projects are going to create a website. In this case, that website spits out other websites. In this case, that website spits out videos. Cool. Super excited for this one if someone builds it. Moving on. Full stack projects, not CRUD applications, something extra. I'll talk through the challenges and why these projects have found decent product market fit. The first one is a Riverside clone. I don't know how many of you have used Riverside FM, but I've been a happy customer for around a year now. It is a podcasting platform and one that is used in this podcast between Gary Vee and Mark Zuckerberg as well. That means it's popularly used. It's also very trusted. The reason I say it's trusted is because when you are doing remote podcasts like this, it's very important that the video doesn't get lost. That is why people do local recordings. In fact, my old podcasts, I used to go to meet.google.com, send a link and record the whole thing locally. Now I've moved to Riverside because one, there is high reliability. The podcast that I'm shooting, I'm sure I'll get back the raw files. And number 2, it's very convenient. It's very hard to do a local recording. My machine starts to stutter. But in case of Riverside, the way they work is the people that are on the call can talk to each other via WebRTC. So we are each seeing each other's video in low quality. There are frame drop-offs. So it feels like, the final output would also be bad. But no, they're actually doing a local recording as well. So in this case, Mark Zuckerberg and Gary Vee are talking to each other via WebRTC, low quality video. That video gets discarded after the podcast, but Gary Vee is recording on his local machine as well in the browser. Same is true for Mark Zuckerberg. And as the video progresses, as the podcast progresses, slowly these high quality chunks go to S3. So the things that you need to learn are WebRTC for two-way communication amongst them, and S3 or general any object store multi-party uploads, basically breaking the video down into various chunks and slowly uploading them to your object store. That way, if the podcast ends, and generally this happens on Riverside, after the podcast ends, you have to stay there for 10 minutes to upload your local recording and make sure all the chunks are uploaded. If you're on really good internet, it happens immediately. But even if you're on bad internet, even if your internet goes away, even if you shut down your machine and restart, all the parts, all the local recording is there, and it slowly gets uploaded to Riverside. Cool. High focus on reliability and resiliency. I've added another point here called video rendering. Riverside does not provide this. Riverside by the end gives you all the raw files and a timeline of events. Okay, Gary Vee joined at t equal to 0, Mark Zuckerberg joined at t equal to 1, Gary Vee started to screen share at t equal to 3, so on and so forth. So there is a timeline of raw files, but generally it is expected for the editor to download those files and then go into an editor and actually render the whole files. It would be nice if you can let the user at least provide the user with a full podcast automatically rendered, all the videos merged. If there are 3 people initially, you see a 3-person layout. If 5 people join on the 5th minute mark, then the layout changes. These are all hard challenges when you're trying to render a video where people are coming in and out beach mein. If there is a fixed layout of 2 people, that's fine. But as people come in and out, if you start to screen share, the layout changes. Rendering a video like this without a Premiere Pro like editor gets a little challenging. So that's another feature I've added. Feel free to decide if you want to join or not. I'm assuming they're doing really well because the churn is really low, because I've bought this once, and even if I don't do a podcast, I still pay them $20 a month because it's super convenient compared to recording locally. That's one. The second one is Tally, which is a form builder closer to a Google Forms, or what's the other one? Type Forms. But it differentiates in 2 ways. One, you generate if you've ever created Google Forms, it's very complicated clicking on buttons. It's very easy to create a Notion page though. And the way you create a form over here is closer to how you create a Notion page. So, you have commands to create a heading, to create an input box, to create a text box, so on and so forth. So it's just more convenient. That has a bunch of UI challenges that you need to deal with. So, one of the things to learn over here is how do you build a new Notion like UI. But the other big thing that they provide is integrations. One thing you need to know is the people who are paying for a product like this are people who are trying to gather leads and, convert them into sales, or, they're really high quality leads for them. And hence they want to make sure whenever someone signs up, it automatically reaches Google Sheets, or it automatically reaches Notion, or it automatically, triggers a workflow to message them on WhatsApp via Zapier or Make, so on and so forth. So if you would want someone to pay for it, you would need, that's something Google Forms does not provide. So a big differentiator compared to a free Google Forms is, okay, whenever leads come or whenever your form gets hit, you can integrate it with various external services and make sure you have visibility to who's registering and, talking to them, whether they're a warm lead or a hot lead or a cold lead, so on and so forth. And lastly, another feature I've added over here is GPT to summarize, which means it would be nice if I put out a form, let's say, super 30 registrations and 1,000 people fill it. I need to filter out top 30. So it would be nice if, you can forward that to an LLM and it can try at the very least to find, some relevant leads over there, or just summarize the whole form for me. Cool. That's the second one. The difficult bit here is going to be Notion like UI and adding integrations, because every integration will have its own API. So integrating with them, getting their API keys, so on and so forth is a challenge. But a very breadth product. It has like a lot of things you have to build, and hence, that's where most of your time will be consumed. That covers full stack. This is where I wanted to end the video, but I've added a bonus section because, as I said, a lot of hiring is happening for this engineer, probably because this requires some human effort. The way you differentiate yourself from an AI, if you have, a design eye and something people would always want, someone leads front end to end. So the first one is going to be, it's a weird project, but an LLM interface. I don't know how many of you have seen P3.chat, but it's a simple wrapper on top of, OpenAI models, Claude models, Mistral models, DeepSeek models. People are very comfortable with this interface now, but not a lot of innovation has happened on this interface. That's exactly what they exploited. They created a very clean UI. And when you actually use it, you'll understand, it has a lot of subtle things that makes this a very convenient UI to interact with an LLM. They've also priced it down compared to ChatGPT or Claude. It's only $8 a month. They can afford to do it because at scale, people don't really, if you pay $20 a month to ChatGPT, you're not sending them 20,000 requests. Some months you're only sending them 5 requests. And hence the math works out. So they provided 2 big features. One, you can talk to all the LLMs from here. 2, they're really fast. And another feature is they're cheaper than all other UIs. And hence, amongst a lot of chaos and a lot of AI labs making a lot of money, here comes a project that was able to differentiate and sort of compete with them directly. Of course, they still have to pay OpenAI under the hood for the LLM calls. Yet you can actually accrue a lot of value if the UI is differentiated from others. That's exactly what they did. 2 big challenges here. One, the UI is really good. Just go through it, you'll understand. So this is, if you create a cleaner UI, you may or may not be able to win the market, but at the very least, you have some product that seems very simple. yet, you can actually win the market based on the product. Number two, I don't know how they do it, but their LLM responses are really fast. So we need to figure that out. I don't know if that's a front end hack that they've added, or if, I don't know, they're sitting most closer to the models wherever the models are, eventually deployed in US. I don't know. But if you ever try this and compare it to the response with a native UI like a Claude UI, you'll find this is much faster. Figure out how that is. I have no idea. That's the first one. The second one, two people I've referred recently. One failed. I think his UI library was called, I forgot, Rangoli UI, I think. And the other guy just referred today. Both of them had their UI libraries. Great proof of work if you want to be a design engineer, because if you can build your own components, let's say 20 components that are really good, very unique, very hard to build, have some animations, or just are very jazzy, then it's decent proof of work. Okay, when you join a company as a front-end engineer, you'll probably be able to add an input box or border, or change CSS somewhere. That is what your job will look like anyways. And hence, if you've built any one of these, at least if you're applying for a design engineer role, probably would just consider it to be a prerequisite. Okay? Have your own 20 components. You don't have to build a full-blown UI library, but have 20 components that are elegant, that you've built somewhere and you have proof of work to show. If you want to build a full-ass UI library, you can build it on top of 𝗟𝗶H. You don't necessarily have to have your own CLI. But let's say you do, then this is a decent project to look at. It's called Hero UI. It's open source, so you can go through its code base, or go through 𝗟𝗶H code base. The things that you have to build is the CLI, a command line interface that people can use to bring the components locally into a React project or a Next project. Components, which is the core logic here, this is where you show your design skills and how can you build something fancy. It could be anything. The one that I saw today, the person that I referred, he created like an admit card like UI, which the admit card would flow closer to how, I don't know if you guys can see this, but this is flowing. So basically some level of physics, some level of liquid physics in there. And colors were really great. The design looked really good, and that was enough to grab my attention. I saw his portfolio. I saw there was a UI library in there. Components were decent. I referred. So if you're thinking of getting into a design engineer role, you can build other projects as well. But this one might be a good one to put in. If you do build one, then make sure you're building good components, and also add a storybook. So it's just very easy to look at all the components that you've built. Cool. If you want to build this end to end, make sure all three are there. Tag me on Twitter. Let me know. Would love to see what you've built. Build these end to end. If you do feel like you have a lot of motivation right now, pick one. Do not pick 20 together. Pick one of these. Build it end to end. It's very easy to build these in 2 days. Like one version that's working, and then very hard to productionize it. And make sure it's on the internet. It is working. It will stay up. The database is there. It's stable. You understand the whole process. There is reliability. Make sure that that's all there. When you're forwarding this to a recruiter, they don't have time. And what you're really looking for is, on a boring day where you're sifting through 50 applications, one that catches your eye and immediate interview. So that's what you're optimizing for. For that, make sure the final product that you've built, it's better to build this one project for a month than trying to do 10 different things, here and there, and have projects that no one's looking at. Hopefully that's obvious, advice by now. Okay, one project that's really good is enough to grab attention. If you do build it end to end, if you actually understand, this is impressive of a project, tag me with the live link and the GitHub. That's how usually I've been able to grab people right now, and some of these are from the cohort, some of these are just people I found on Twitter. So you don't necessarily have to be associated with us in any way. If they're good enough, if they're in this niche, I'm happy to refer. And make sure you have a live link, make sure it's deployed on GitHub. The other call out is, which one of these projects do you want me to build end to end? Let me know. The most upvoted one is what I will build. With that, we will end it. I will see you guys in the next one. Bye bye. Alrighty, good video. तीसरी बार